All right, all right, all right. Let's have a quick review of the stuff that we did before break. Fine, let's just talk about the coordinates of the vertex. So this is our parent function thing we based everything off of. What is the vertex here? We should know that one. Yeah. So 0, 0, of course, is the vertex there. So number 2, what is this going to do to my parabola and also my vertex? Yeah, shifting it up 2, so the vertex is 0, 2. Okay, so it's taking that parabola, shifted it up, no left, no right. What is this doing to my parabola? Okay, so it's a little bit wider, it's upside down. Did the vertex move? No. All right. Then we get to problems like this, problems that have an x in them, a plain x term, and of course that was the last thing that we learned, and we talked about a formula to help us find the axis of symmetry, which we then use to find the vertex. What was the formula to find the axis of symmetry? So, I don't have a C here, I got a 0 out there, so I just take my numbers, plug them in. Negative 5 over 2 times 1 is 2.5. So I know my x is 2.5, then I take that, plug it in, 2.5 squared minus 5 times 2.5, so that's 6.25 minus 12.5, so negative 6.25. So it's 2.5 negative 6.25 for the vertex. So last week we talked about the parent function. We know that the parabola has a vertex at 0, 0. If we flip it, if we stretch it, that doesn't affect the vertex. We talked about vertical shifts and how that would affect the vertex. And then, of course, the big thing we talked about was this right here. When we added the x term, we used the formula negative b over 2a and worked from there. All right, so that's a recap of finding the vertex. Obviously not everything, but finding the vertex of the stuff we have done last week. So now we're going to be talking about parabolas that are in this format, right? Here, a equals x minus h, the quantity squared. And some interesting things happen. So first off, let's do a little testing here. So what do you think's going to happen? Let's just think for a second. We know if I put a number out here, outside, what is that going to do? If I put a number out here, what does that do to our parabola? Yeah, so what do you think if I put a number in the parentheses? What do you think that's going to do to our parabola? All right, let's find out. So, again, like we always do, let's just kind of plug and chug to start off with. If I put in 0, 0 minus 2, negative 2 squared, positive 4. Put in 1. 1 minus 2 is negative 1. Negative 1 squared is positive 1. Put in 2. 2 minus 2 is 0. 0 squared is 0. Starting to see some familiar numbers show up over here. Put in 3. 3 minus 2 is 1. 1 squared is 1. Put in 4. 4 minus 2 is 2. 2 squared is 4. So let's plot these points. 0, 4, 1, 1, 2, 0, 3, 1, 4, 0. So I've got my parabola right there. What did that do compared to the original x squared? What happened? Yeah. This right here shifted it right to. You probably would have guessed left if you would have guessed a direction here. Very important, and we've touched on this a little bit before on something else we did. It's the opposite of what you see in parentheses. And that's pretty standard for pretty much any function. We could talk about x cubed, we could talk about sine, we could talk about any base function. If you put it in parentheses, you're generally going to deal with the opposite of what's in those parentheses. So this x minus 2 is going to shift things right to. So again, you know where the original would be. We shifted right to because of what's going on here. So with that in mind, if f of x is this, if I double it, what's this going to do? Yeah. Shift this skinny fraction right to. So we're back to the applications by learning what those manipulations do. This one takes it right to. All right. So if this is going right to, what's this doing? Absolutely. So this one says start with upside down. And obviously my board's off. And then I'm going to go plus 2 is going to make me go left 2. For my function. You should be a little neater in your notes, and you should be writing this in your notes. Graph paper's available. All right. But that's the basic idea. The stuff in parentheses is a right-left shift, and it is the opposite of what you see in parentheses. All right. So this just basically says this. Don't write any of these words down because they're really confusing, or any of that. But write that down, and if you haven't written it down yet, write yourself a note in your notes that says the opposite of what's in parentheses. So, right here, if I want to compare this to the original function, let me go ahead and set the board while I'm talking. The number in front, we already talked about, is that stretch. It doesn't change anything. Right and left wise, just give us a stretch. So, the original, always have that in mind. We know where that goes. What is this going to do? Yeah, it's going to make it half as big. So I'm going to do that in blue. Half as big, half as big. What is this going to do? Be careful. Yeah. So it's going to take all of these points and shift them right forward. So there's our answer. Squish by half, shift right forward. All right. I think they actually call that a horizontal stretch on Big Ideas. Okay. But a vertical squish, squish, stretch by half. Is that the thing? And then shift right. All right. Let's do it again. So graph these two on your own. All right, I put the original on there for just a reference point for you. You may not need that, but the way I would do this, if you watch me do it, I'm gonna take my vertex, go left 5, and instead of going 1, 1, I know I'm stretched, so I'm going 1, 2. And then I'm going 2, 4. Those comparisons, those relationships don't change. I don't need to memorize that this is actually negative 3, 8. I just know it's 2 this way and 2 this way. And if I go 1 this way, it's 1, stretch, 2, 4, stretch, okay? Just memorize the relationship when you start getting this right-left shift. I don't actually have to know the numbers. So here, same idea. That's gonna flip me upside down. So I know the original is here. I flip upside down. I go here. That's going to take me right 2. So I'm going to take everything right 2, right 2, right 2. And I have my function. All right. Any questions on these? All right. Now we can do both shifts at once. So again, a lot of words you don't need, except that this is called the vertex form of the equation. Because when I look here, this is going the opposite of what's in parentheses. You just take exactly what's out there. And when I do that shifting around, my vertex is the numbers in the problem. This is the vertex. It's the opposite of what you see here and exactly what's out there. That gives me my vertex. So now I know where my vertex is. So these become really quick to graph. So if I want to graph this, where is this going to go? Yep, left 2. Where's this going to go? Yeah, exactly what's outside. So it's going up 3. So this is going left 2, up 3. Write that in your notes, okay? You'll get used to it. So I know my vertex is going left 2, up 3. Now if I remember my relationships, is there a stretch? Yeah, there's a -2 stretch. So that's going to stretch it and flip it upside down. So I'm going upside down. So normal would be right 1, up 1. Okay? But now I'm stretched, so I'm going down 2. Normal would be right 2, up 4. Okay, so I'm going to go right, I'm going to go down, and I'm stretched 2, so I'm going down 8. 1, 2, 3, 4, 5, 6, 7, 8. So again, I don't actually know what coordinate that is. I don't really care. What I care about is what's going on and what is that relationship. All right, again, I memorized that original chart, the one we did the first day, and I'm going 1, 1, but I'm starting at the vertex. So now I have symmetry, so I know this one's here, and this one's here, and I have my graph. All right, let's do it again. That's not what I want. Try and graph 6 and 7 on your own. So I'm going right 1, up 6. There's my vertex. From there, I'm going a stretch 3. So again, I have my relationship. I'm going 1, 1 becomes 1, 3. I don't have a whole lot of room. I'm going to do my symmetry. There's my graph. Over here. Left 4, down 2. There's my vertex. What's this doing? Half stretch. So instead of going 1, 1, I go 1/2. I don't like graphing that. It's kind of kind of hard. So instead of going 2, 4, I'm going to go 2, 2, because it's half as big. I'm going to do my symmetry. I could go 4. 4 would be 16, instead it's 4, 8. Do my symmetry. There's my graph. Use the relationships that you learned, 1, 1, 2, 4, 3, 9, etc., and treat them as ways to move from the vertex, because now we have this vertex form. And so I can just manipulate off of that vertex. All right, we'll talk about that. We're going to spend another day on this, okay, but that's the basics. Good luck. Get to work.